Hi, I'm Michael Cohn from Advanced Tubular Technologies. I'm the developer of VTube-LASER software that connects to the FARO arm that's used to measure tubes in order to correct tube bending machines so that we get to the correct tube shape quickly. What I'd like to concentrate on today in this video is how to reverse engineer a part like this using only the ball probe. So, let's get started. First, we start with a clear project, and I'm going to start by entering a part number like this. Now I'm going to go into Measure Setup, and I'm going to uncheck anything that has to do with laser, like this. Go into Measure Process. I want to know what the diameter is. I'm going to go ahead and measure the diameter first. So I've loaded in Uniscan, a cylindrical tube just for the diameter. So what we do now is we take 3 points as if it were a stripe, like this. And then we take any number of points in the middle, and then we take 3 points on the end, like this. Then we press the red button. This is a 1.25 inch nominal tube, so I'm going to go ahead and just change this over to 1.25. I'm going to copy that value to the nominal value, and I'm going to copy it to the BN value. I'm going to make this the AN, the part that comes out of the bender first, so there's BN, same as the nominal. Let's find out what this is. When you finish by hitting a red button inside this control, it's ready to measure a diameter immediately again. So I'm guessing that this is probably supposed to be closer to 1.5 inch nominal expansion on the end here. So I'm going to go ahead and copy that to A end, stop the measure process, and then what I'm going to do is just show you where that shows up inside the part setup menu. Right here, here, and here. But we really should get a default bend radius now. So let's go ahead and just measure that with a ball as well. Again, what we're going to be doing is simulating stripes with our point collection here. So I'm going to take a stripe, and a stripe, and a stripe. Each stripe has 3 points. Red button. Try to collect 4 or 5 stripes. In this case, I think I'm going to get 4 in here. And that will be enough because I've covered the entire bend. Press Calculate the radius from scanned. And I know that this is supposed to be about a 2-inch bend radius because you can see it calculates 1.959. So let's just nominalize that at 2. Copy this to the default radius. Stop the measure process. And now we're ready to measure the part itself. Go back into Measure Process. Click on the first Uniscan button on the top like this. Count the number of straights. 1, 2, 3. Enter that value here. Press Measure Tube Now, click Continue, and then follow the instructions on the screen. First we're going to take some points on the end, like this. Now let's say I make a mistake and take a point out here. That's definitely not going to work because our end trim is going to be out here now. What I need to do is take the mouse, click on this checkbox, and I'm going to turn the DRO on so that you can see this happening. In the points in memory value, we see 10, so I'm going to hit the red button. Now we'll see 9. So I just got rid of that point that's out here. So let's uncheck this box. Let's hit the red button because we're finished. And now we're going to go ahead and measure the next straight. You might have noticed I didn't do any kind of probe compensation because we're not really thinking as if this is a plane. What we're looking for is the furthest point out relative to the projection of the center line. So what we do next is going to form the direction for that trimming. We're going to measure 3 points here as if it's a stripe again. Make sure this first set of points is as close as possible to the end, and that the last set of points is as far as possible from the end. Otherwise it'll get the vector mixed up. If you orbit around on the screen in orbit mode, you're going to see that the orange ball should be on the tube side of all of these points because those points represent the center of the ball, so it should have projected that way, and it did. So now it's asking for straight 2. All right, I'm going to click here on Finish and Apply. We don't have any master data yet to align to, so we can't really use these buttons here. But we can build a measured tube like this. The measured tube will be blue. What we need to do is turn that measured tube into the master tube. So we're going to go to Data Handling, copy measured to master like this. A lot of customers like to reset the origin to 0 in order to clean up the data. It's the same part, it's just translated in space. And then what I like to do often is I like to go into inspection results and align the two. That basically proves that this is truly the same part. The deviation should be exactly 0 because we're aligning the part to itself. Now let's say you want to set up the bender next because you've got your data. You can come into the reports menu here and you can then look at the bender data. You can actually print this out, take it out to a bender, manually enter the data into the bender, bend the part, bring it back, and then perform the qualification process. What I'm going to do though is I'm going to just assume for a moment that you have a connection to your bender, which is even better. What we're going to do is go into bender setup like this, and I'm going to set up this window by bringing all of the data into this window. The data in this window is going to be sent out to the bender like this. We're going to set the bender up by hitting one of these two buttons. In fact, what I just did was simulated setting up bender number 1. You can set up to 100 benders using this process. The data that was sent out was the data in these blue columns, the bender data, the length, rotation, and the angle. I'm going to go out to the bender, bend the part, bring it back here, exit to laser, and then I'm going to measure that part again, and at the end of that measurement I'm going to perform an alignment to see how close it fits. If the part doesn't fit, then what we're going to do is go into bender setup again, and we're going to come into this bidirectional communication menu. We're going to ask the bender to update the blue columns because that's the data that the operator used last to bend the part that's in the clamp. And then we're going to send the corrections out in the orange columns back to the bender. And those corrected values are then going to allow the bender to adjust in order to get to the correct shape quickly and allow us to then have the part ready to run after maybe 1 or 2 or 3 corrections. So that's how you reverse engineer a part using the ball probe. It's that simple. If you have any questions about this process, please feel free to email me at michael.cohn@advancedtubular.com. Thanks for taking the time to watch the video. Have a great day.